Humbug Whistle? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Hi, in the given problem, length of the string is given as L is equal to 50 centimeter, or we can say this is 0.5 meter. Mass of the block attached with the string is M is equal to 200 gram, or we can say this is 0.2 kilogram. Frequency, the rate of rotation is given as 75 revolutions per minute, or we can say this will be 75 by 60 revolutions per second, which comes out to be, after cancelling by 15, it will be 5 by 4 RPS, or we can say this is 1.25 RPS, revolutions per second. Now, in the first part of the problem, we have to find the speed of the block. So that will be given by V is equal to L into omega, where omega is the angular velocity, which is given by the expression 2 pi into F. So plugging in all known values for length, this is 0.5 meter into 2 into 3.14. And then for F, this is 1.25. So finally, this velocity here will come out to be 3.9 meter per second. And here it becomes the answer for the first part of the problem. Now, in the second part of the problem, we have to find the tension in the string, and that tension in the string, and that will be inward, radially inward, will be equal to the centrifugal force acting on the block radially outward. And we know the expression for that centrifugal force is mv square by r, means the radius, which is the length of the string. So for mass, this is 0.2 kilogram. This is 3.9 to the whole square for velocity, divided by 0.5, the length of the string, which comes out to be 6.2 Newton, the tension in the string. And here it becomes the answer for the second part of the problem. Thank you.
Humbug Whistle? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Electron mass is equals to 9.1 into 10 to the power minus 31 kilogram. Distance between proton and 5.3 into 10 to the power minus 11 meter. Force is equals to 8.2 into 10 to the power minus 8. This force exists to centripetal equals to capital F is equals to n omega square r. Hence omega is equals to under root capital F upon mr, which is equals to under root capital F here 8.2 into 10 raised to power minus 8 divided by 9.1 into 10 raised to power minus 31 multiply 5.3 into 10 raised to power minus 11. Hence omega is equals to 0.412 into 10 raised to power 17 radian per second. Hence omega is equals to 0.412 into 10 raised to power 17 divided by 2 into 3.14, which is equals to nearly equals to 6 into 10 raised to power 15 revolution per second.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Here given curve of the radius is equal to 500 meter. Speed small v is equal to 90 kilometer per hour, which is equal to 90 into 1000 divided by 60 into 60, which is meter per second. And banking angle is equal to theta. We have to find. Now here we have theta mg normal direction. We have mg square upon r theta mg. Now n sine of theta is equal to mg square upon r. N cos of theta is equal to m. Now n sine of theta divided by n cos of theta is equal to mv square upon r mg. Hence, tangent of theta is equal to v square upon mg. Now, theta is equal to tangent inverse v square upon mg, which is equal to tangent inverse v square is 900 divided by 36 square 0.8. We get theta is equal to tangent inverse 0.127, which is equal to theta is equal to 7.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Hi, in the given problem, if moon is tied to the earth with the help of a cable, then tension created in that cable will be equal to the centrifugal force acting on the moon radially outward. So that tension will be given by in expression equal to centrifugal force, which is given by mv square by r. Here, m is the mass of moon, which we found to be 7.35 into 10 raised to the power 22 kilogram. V is the orbital speed of the moon around the earth, and which is found to be 1.022 kilometer per second. And finally, this r is the orbital radius of the moon around the earth. And it is found to be 3.48 into 10 raised to the power 8 meter. So plugging in all known values, this tension in the string will be given by, for m, this is 7.35 into 10 raised to the power 22 kilogram. For speed, this is 1.022 kilometer per second, or 1.022 into 10 raised to the power 3 meter per second to the whole square, and then divided by orbital radius, which was given as 3.48 into 10 raised to the power 8 meter. So rearranging all these numeral values, here it becomes 7.35 into 1.022 to the whole square divided by 3.48 into 10 raised to the power 20 Newton. So finally, this tension in the cable here comes out to be 2.21 into 10 raised to the power 20 Newton. And this is the answer for the given problem. Thank you.
Homework Baser? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
So here in this question, the net force that the track exerts on the ball is the centripetal force. The centripetal force is given by Fc, and that is mv square upon r, where m is the mass of the ball, v is the speed of the ball, and r is the radius of the track. In this case, the mass of the ball is 30 kg, so the centripetal force is equals to 30 into 10 raised to the power minus 3 into 60 into 2 pi into 0.2 upon 0.2, and that is equals to 18 pi Newton. Now the magnitude of the net force on the track exerts on the ball is 18 pi Newton. Is 18 pi Newton. So I hope this answered your question. Thank you. This is the centripetal force and the net force, that is 18 pi Newton. So I hope this answered your question. Thank you.
Homework Baser? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Q1. There is satellite revolving around the moon close to it. The time period of revolution is 110 minutes. We need to find the free fall acceleration on surface of the moon. By using this equation, capital T is equals to 2 pi under root small r upon g. We have the radius of moon Rm is equals to 1.74 into 10 raised to power 6 meter. Hence, 110 multiply 60 seconds is equals to 2 into pi of multiply under root 1.74 into 10 raised to power 6 divided by gravity of moon. Hence, we get 1.74 into 10 raised to power 6 divided by gravity of moon is equals to 6600 divided by 6.28 whole term. We get the gravity of moon is equals to 1.58 meter per second square. Acceleration due to gravity on the surface of moon is 1.
Homework Baser? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Small g is equals to capital Gm upon r square, which is equals to 6.63 into 10 raised to power minus 11 multiply 1.98 into 10 raised to power 30 divide by 149.60 multiply 10 raised to power 9 raised to power 2. Hence we have 6.63 into 1.98 multiply 10 raised to power 21 divided by 149.6 multiply 149.6 multiply 10 raised to power 18. We get 0.000586 multiply 10 raised to power 6 meter per second square.
Homework pencil? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Consider the maximum speed is v and mass of the car is m. When the car moves in a path, speed is v and mass is m. When the car moves in a path which are arc of a circle, the car will experience centrifugal force. The car will fly off if the centrifugal force is higher than the weight. So the maximum possible speed of car is when the centrifugal force is equals to the weight. Hence, the weight of the car is W is equals to mass into gravity, and the centrifugal force of the car Fr is equals to mv square upon r. Now equating the forces, we have mg is equals to mv square upon r. Solving for v, we have v is equals to under root gr. Now substituting the values, we have v is equals to under root 9.81 meter per second square into 50 meter, we get 22.1 meter per second. The maximum speed of the car can have the top without.
Homework pencil? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Hi, in the roller coaster, this is a dip in the path where if the mass of the car is m, its weight mg will be acting vertically downward, and a centrifugal force will also act on this car, and that will also be acting vertically downward. M, which will be given by m into v square by r, where r is the radius of this circular track. So the normal reaction exerted by the track on the car or on the passenger will be given by n is equal to mg plus mv square by r. And actually here this n is the apparent weight. Of the passenger. It is given in the problem that this apparent weight is increased by 50%. So as the apparent weight has been increased by 50% means we can say it must have become 150% of the original weight. Original weight, which is given by m into g. Hence, we can say this n is 150% of mg, and that is equal to mg plus mv square by r. Means 1.5 mg, and then we can shift this mg also towards left hand side, minus mg, it will become is equal to mv square by r. So finally this is 0.5 mg is equal to mv square by r, cancelling this m. Finally, the expression for speed of this car over the roller coaster will come out to be 0.5 into rg, having a square root. So plugging in the known values, this is 0.5 into radius, and the radius of this curved path of the roller coaster has been given as 30 meter into g, which is 9.8 meter per second square. So finally, this speed comes out to be square root of 147 meter per second, or v is equal to 12.1 meter per second, which is the answer for the given problem. Thank you.
Homework Pencil? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Here, weight mg in downward direction, capital N, fr in upward direction, from center to r, small r is the radius. The speed of the roller coaster car at the top of circular top is twice the critical speed. We have to calculate the ratio of normal force to the gravitational force. We know that the critical speed is given by V critical is equals to under root of small gr, where g is the acceleration due to gravity and r is the radius of the circular loop. Now the speed of the car is small v is equals to 2vc is equals to 2 of under root critical velocity, which is small gr. Hence the centripetal force is Fr is equals to mv square into upon r, which is equals to m into 4gr upon small r, which is equals to 4 mg. Now equating the forces, we have capital N m plus n plus mg is equals to Fr. Now solving for n capital N, we have n is equals to Fr plus mg is equals to Fr. Now solving for n, we have n is equals to Fr minus mg, which is equals to 4 mg minus mg, we get 3 mg. Now the gravitational force is given by capital W is equals to mg. Hence the ratio is n upon W is equals to 3 mg upon mg is equals to 3. Conclusion: the ratio of normal force to the gravitational force of the roller coaster car is 3. The ratio
Homework Pencil? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
here we know the diameter of the loop. We have loop from center. We have radius r, downward force capital M, and mg, weight, which is also acting in the downward direction. In the upward direction, we have fr. We know that the diameter of the loop is small d, which is 40 meter, and the normal force capital N is equals to the gravitational force W. We also know that the acceleration due to gravity is g is equals to 9.81 meter per second square. We have to calculate the speed of the car at the top of the loop. Solution: consider that the mass of the car is equals to small n, and speed at the top is small v. Now the radius of the loop is small r is equals to d by 2, 20 meter. Hence the centrifugal force experienced by the car Fr is equals to mv square upon r. Now the gravitational force on the car is W is equals to mg. Hence the normal force is capital N is equals to Fr minus mg. Now equating the gravitational force and normal force, we have omega is equals to capital N. Hence mg is equals to Fr minus mg. Hence we get 2mg is equals to mv square upon r, which is centripetal force. Now solving for v, we have v is equals to under root of 2 small gr. Now substituting the values, we have v is equals to under root of 2 into gravity 9.81 meter per second multiply 20 meter. Here we have 19.8 meter per second. The speed of the car at the top of the loop is 19.8 meter per second.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
In this problem, we're going to talk about circular motion. So consider that we have a circular trajectory of radius r, and we want to describe the dynamics of this trajectory. So we can decompose the acceleration into two components. So one of them is the centripetal acceleration, and that is equal to omega squared times the radius r, where omega is the the angular speed, and it accounts this acceleration for the change in direction of the trajectory, uh, and it's present even when the speed is constant. And there's also the tangential acceleration that accounts for the change in speed and is equal to dv dt. In our problem, we have a student that has a length, whose arms have a length of 65 centimeters, that's swinging a bucket full of water in a trajectory, in a circular trajectory, and a vertical circular trajectory. Okay, so the gravitational acceleration is present, and we know that the distance h between the handle of the bucket and the bottom of the bucket is equal to 35 centimeters. And our goal is to find what must be the angular velocity v of the bucket so that the water is not spilled. So let's consider the situation where the bucket is up here in the highest part of the trajectory, full of water. Consider that the forces that act on the water are the gravitational force, mg, and also the force, I'm going to call it just F, that the bucket exerts on the water. Okay, so we have that F plus mg must be equal to m omega squared over r. I'm sorry, omega squared times r. Okay, so the total force is equal to the centripetal force as it should be. Now, the minimum force that the bucket must exert on the water such that the water doesn't spill is zero. Okay, from the moment where there's no force being exerted over the water, then the water will be spilled if this force is exerted for more than a moment of time. So I'm going to impose in the limit scenario that f is equal to 0 to find the minimum value of omega. So mg is m omega squared r. The m's cancel out. So omega is the square root of g over r. And that is equal to 3.13 radians per second. Since we want the answer in RPM, in rotations per minute, then I'm going to divide by 2 pi in order to obtain the frequency, and multiply it by 60 to obtain the frequency in RPM. And that's 30 rotations per minute.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Hi, in the given problem, diameter of the circular track is given as 200 meter. So its radius will come out to be r is equal to half of the diameter, means 100 meter. Tangential acceleration is given as at is equal to 1.5 meter per second square, and we have to find the time t, after which the centripetal acceleration will become equal to this tangential acceleration, means 1.5 meter per second square. Now, the expression for centripetal acceleration is v square by r. So v square by r should be equal to 1.5. Hence, we can say this v square should be equal to 1.5 times of r, or 1.5 times of 100, means this should be equal to 150. So the speed over this circular track must have become square root of 100 and 150 meter per second, means it should be equal to 12.25 meter per second. So now, using first equation of motion, which says v is equal to u plus at, and a means the initial speed was 0. So this is 0 plus a, which was 1.5 meter per second square, and the speed, this is 12.25, is equal to 0 plus at means 1.5 into t. So the time required should be given by 12.25 divided by 1.5 seconds, means the answer for this given problem is 8.2 seconds. And this is the answer for this given problem. Thank you.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
A. We know that the diameter of the track is small d is equals to 1.0 meter, and the coefficient of friction is mu, which is equals to 0.10. We also know that the acceleration due to gravity small g is equals to 9.81 meter per second square. We have to calculate the angular acceleration of the train. The angular acceleration of the train is alpha is equals to at divided by r, where at is the tangential acceleration of the train and r is radius, which is diameter upon 2, is the radius of the track. Now the acceleration of the train is due to rolling friction. Now the acceleration due to friction is given by at is equals to mu g. Here the angular acceleration is given by alpha is equals to at upon r, which is equals to mu g upon r, which is equals to 2 of mu g divided by d. Substituting the values, we have alpha is equals to 2 into 0.10 multiply with 9.81 meter per second square divided by 1.00 meter. Hence we get 1.96 radian per second. And the magnitude of angular acceleration of the train is 1.96 radian per second square. Part B. The initial angular velocity of the train is omega I is equals to 30 radian per second, or we can say per minute, and convert it into second, we get 3.14 radian per second. To find the final angular speed is equals to 0, and the acceleration alpha is equals to 1 minus 1.96 radian per second square. Here negative sign indicates that the acceleration is in opposite direction to the velocity. We have to calculate the time taken by the train. Solution: the kinetic equation is omega f is equals to omega I plus alpha t. Solving for t, we have t is equals to omega f minus omega I divided by a. Initial angular acceleration and final angular acceleration. Now substituting the values, we have t is equals to 0 minus 3.14 radian per second divided by minus 1.96 radian per second square. Hence we get 1.60 seconds. Conclusion: here the train will take 1.60 seconds to stop.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Here given ay is equals to g, which is equals to 9.8 meter per second square. After then mass 0.1 kg. After then mu k is equals to 0.5. Delta s is equals to 2 meter. Delta h is equals to 1 meter. Delta x is equals to 0.3 meter. Given. Now find mu naught. If we read the problem carefully, there is two-part problem: the deceleration of the object before falling and the free fall motion of the object. Now part 1, for event 1, here A, N, F, Mg, M. This is for event A. Now H height, X distance, M mass, which is supposed to fall here. It is event B. Event B, vertical component HF is equals to H naught plus V naught y t plus half at square. Hence we get HF is equals to 0 plus half AT square. Hence small t is equals to under root of 2h final upon AY. Hence t is nearly equals to 0.45. Solve event B first because most given are usables there with kinematics. Solve for t in the vertical component with kinematics. Now horizontal component. Here xf is equals to x naught plus v naught xt. Hence 0.3 is equals to 0 plus v naught x into 0.45. Hence v naught x is equals to 0.3 divided by 0.45, which is equals to 0.66 meter per second. Velocity of event A. Now event A, n is equals to mg. Max is equals to minus f. Hence max is equals to minus ukmg. Ax is equals to minus ukg. We can create an equation for acceleration in the x direction using the force diagram for event A. Hence, Fx square is equals to v naught x square plus 2ax delta s. Hence, v naught x square is equals to vfx square minus 2 minus mu kg into delta s. Here we get v naught x is equals to under root of 0.66 square minus 2 minus 0.5 minus into 9.8 multiplied 2, we get 4.5 meter per second. Finally, use another
Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
In this problem, we're going to talk about two-dimensional motion. So consider that we have a force F that is two-dimensional. So we have that F is Fxi plus Fyj that acts on an object that has a mass m. So the coordinates of the particle r are equal to the initial coordinates are 0 plus the initial velocity v0 times t plus 1/2 of the acceleration. And remember that the acceleration is the force divided by the mass. F here is the net force times t squared. And in our problem, we have a rocket that is attached to a puck. Okay, such that the head of the rocket points in the y direction and the puck is over the surface of an ice surface, so a very frictionless ice surface. The mass of the rocket, m, is equal to 200 grams, so 0.2 kilograms, and the mass of the puck is equal to 0.4 kilograms. So the total mass of the system is 0.6 kilograms. The initial velocity given to the system is equal to 2 meters per second in the x direction, and the rocket generates a thrust that is equal to 8 newtons in the j direction. And our goal is to find the curve, find an expression for the curve y of x, and then plot it, sketch it. Okay, so notice that all the forces are in the x direction, so there is a thrust force upwards, but there's also the gravitational force downwards. The gravitational force is 0.6 kilograms times 9.8 meters per second squared in the j direction, and there's a minus here because it's pointing downward. So W is minus 5.88 newtons in the j direction. So the total force is T minus W, so it's equal to 2.12 newtons in the j direction. Okay, so let's write the equations for the x and y coordinates. Notice that there's no force in the x coordinate, so it's all gonna behave as a uniform motion. So x is equal to v times t, since v is in the x direction, and y is equal to y0, which is 0, plus v0 in the y direction, which is 0t, plus the acceleration, that's the force F divided by the total mass m, times t squared over 2. Okay, so this is F t squared over 2m. I'm going to isolate t as a function of x. So t is equal to x divided by v, and y is equal to f times x squared over 2mv squared. So y as a function of x is f over 2mv squared times x squared. And I'm going to substitute the number, so f is 2.12 newtons. We have to divide it by 2 times the mass, which is 0.6 kilograms, times v squared, that's 2 meters per second squared, times x squared. So y is 0.44 x squared. Okay, this is our analytical equation, and then we have to plot it. So we have y as a function of x. This is a quadratic function. When x is equal to 0, y is equal to 0. When x is equal to 1 meter, y is equal to 0.44 meters. Then when x is equal to 1 point, when x is equal to 2, I'm sorry, y is equal to 1.76 meters. Okay. So our curve will look something like this. It's a quadratic curve, and this concludes our exercise.